let's start by reviewing our basic function operations. So let's start with f plus g of x. So f plus g is going to be x squared plus 2x minus 1 plus x minus 5. So all we have to do is go through and combine like terms. We just had the x squared, then we have 2x plus x, so that gives us 3x, and then we have negative 1 and negative 5, so that's going to be negative 6. So f plus g of x is going to be x squared plus 3x minus 6. Alright, so let's go ahead and do f minus g. So f minus g of x. So this time I'm going to subtract them. X squared plus 2x minus 1 minus, and I need to make sure x minus 5 goes in parentheses. Alright, and this one we can distribute that negative. So it's x squared plus 2x minus 1 minus x plus 5. Alright, so when we work through that, we still have the x squared. 2x minus x leaves us with x, and negative 1 plus 5 is going to be 4. So that gives us x squared plus x plus 4. Alright, so now we can move on to f times g of x. Alright, so in this case we're going to multiply. So x squared plus 2x minus 1 times x minus 5. You can use whatever method you want for multiplying polynomials. Alright, so I'm going to have x squared times x, which is going to be x to the third. Then I can move to my x squared term, so x squared times negative 5, so that's negative 5x squared. 2x times x is 2x, so negative 5x squared plus 2x squared is negative 3x squared. Alright, then I have my linear terms. 2x times negative 5 is negative 10x. Negative 1 times x is negative 1, so that's going to be negative 11x. And negative 1 times negative 5 for my linear term is going to be positive 5. So that gives me x cubed minus 3x squared minus 11x plus 5. And finally, we have our division. F divided by x, or sorry, f divided by g is equal to x squared plus 2x minus 1 divided by x minus 5. And for now, we can just leave it like that. We'll talk about long division another day. Go ahead and try these for example B. We'll show that in another video. Alright, function composition is when we are substituting one function into another. So f of g of x, that open dot here means to compose. Alright, so another way we can write that is f of g of x by doing an inset. Alright, knowing that we have to substitute g into f. Alright, so we want to find each composition and determine its domain. So in example 1, we're going to find f of g of x. So that means I'm going to substitute g of x into f of x. So if f of x is 2x minus 3, so that means I want 2 times. So instead of x, I'm going to use g of x, which is x plus 1 minus 3. And then we can just simplify. So we apply the distributive property. That's 2x plus 2 minus 3. And then we continue simplifying 2x minus 1. So then we want to identify the domain. And the domain, in this case, since it's a linear function, is all real numbers. All right, let's look at example B. So example B, we have f of x is x minus 3, g of x is x squared plus 1. So we want to find g of f of x. So that means we're going to start with the function g and substitute f into that function. So that means I want, instead of x, I'm going to have x minus 3 quantity squared plus 1. All right, really important, when we're squaring a quantity, we treat it as multiplying binomials. All right, it's not just distributing the exponent. So I need x times minus 3 times x minus 3. So if we know our perfect squares, that's going to be x squared minus 6x plus 9. You can also use any method of binomial multiplication, plus 1. So when we simplify g of f, that's going to be x squared minus 6x plus 10. And again, this is a quadratic function, so we know that the domain is going to be all real numbers. All right, go ahead and try these next two examples. All right, so now we can also use the same thing where we are not only composing functions, but also using substitution with them. So let's go ahead and do this for example 3a. All right, so f of x is square root of x, g of x is x minus 2. So that means I'm going to substitute f of g of x. So that means we have the square root of x minus 2. So when we are finding f of g of 6, we're going to substitute 6 minus 2 and then take the square root. So 6 minus 2 is 4, and the square root of 4 is 2. All right, go ahead and try example B. All right, one of the other things we can do is we can break down a function into a composition of functions. So if we want to take something up and break it up, this is something that's going to be really useful when you guys get to calculus. All right, so if we're given a function h of x, we want to break it up into two functions where we can write it as f of g. So what I usually want to start with is what function is embedded in the other. Here I can see that I have something squared. I have this x cubed minus 3x embedded because that's all being squared. So I can break this up into two functions. All right, so f of x is that function of everything I highlighted squared. So that's going to be x squared. And g of x is what we substituted. So we substituted x cubed minus 3x. And that way f of g of x is going to be equal to h of x. Now go ahead and try that with example B.